Section 2.1, Introduction to Equations. First, some terminology. An equation is a mathematical statement that two expressions are equal. It will always contain an equal sign. A solution is any value of the variable that makes an equation a true statement. A solution set is the set containing all solutions of an equation, and equivalent equations are equations that have the same solution set. So consider the equation 2x plus 7 is equal to 4x minus 3. Is x equals 3 a solution? If it is a solution, then it must yield a true statement upon substitution. So 2 times 3 plus 7, is this equal to, does that make that expression the same as 4 times 3 minus 3? Following the order of operations, 2 times 3 is 6, plus 7 is 13. 4 times 3 is 12, minus 3 is 9. Since 13 is not equal to 9, is x equals 3 a solution? No. Why don't you try to determine if x equals 5 is a solution of the equation? Alright, so substituting and evaluating. Two times 5 is 10. 10 plus 7 is 17. 4 times 5 is 20. 20 minus 3 is 17. 17 is equal to 17. So therefore, yes, x equals 5 is a solution of the equation. So now we can actually go into some properties that we can use to help determine the solutions of equations without necessarily having to check a whole bunch of numbers. The first property is called the addition property of equality. Basically what it says is, adding the same number to each side of an equation results in an equivalent equation. We are allowed to add the same number to both sides of an equation without unbalancing the equation. So, if I had the equation x minus 23 equals 5, I am allowed to add 23 to both sides of the equation. Now what happens here is we now have x minus 23 plus 23 is equal to 5 plus 23. Now the negative 23 plus 23, well, these are opposites. And so we now have x plus 0 is equal to 28. And x plus 0, using the identity property of addition, is x. And so x equals 28. And so we can easily check this and say that, and check that 28 is a solution of the equation by substitution. And in fact, it is the only solution of the equation. Sometimes we may be asked to write the solution as a solution set. So as a solution set, we would open the set braces, write the solution value, and close it. Similarly, for the second example, a plus 30 equals 4, we could add negative 30. Now, you might not like that, because you might have seen somewhere in the past that we just subtract. Well, I did just subtract, because subtraction is the same as addition of the opposite. Subtracting 30 is the same as adding negative 30. So if we're more comfortable with that, I'll go ahead and subtract 30 instead from both sides. So we now have a plus 30 minus 30 is equal to 4 minus 30. Again, we have these opposites. So we have a plus 0 is equal to negative 26, and so a is negative 26. Or again, as a solution set, open set braces, the number, close set braces. So here are a couple that I would like for you to now try on your own. It would be a good time to pause. Alright, so if we have a minus 19 is equal to negative 11, we would simply add 19 to both sides of the equation. So a, right, because negative 19 plus 19 is 0, and so now we have a equals negative 11 plus 19, and so a equals 8. 97 is equal to negative 23 plus y. Well, I want to isolate the y, and so what I will do is add 23 to both sides. Negative 23 plus 23 is 0, so I have y remaining on its own on the right. Now I have 97 plus 23 on the left, and so y is equal to 115. And again, set braces if you'd like. The idea doesn't change if we have fractions or decimal numbers. Try these now on your own. Three-fourths plus z is negative 1/2. To isolate the z, I would subtract 3/4 from both sides of the equation. 3/4 and plus negative 3/4 is 0. 0 plus z is z, and that's equal to negative 1/2 minus 3/4. Well, since I'm adding or subtracting fractions here, I need a common denominator. So 4 will work. I'll build up the first fraction by a factor of 2. So I have z equals negative 2/4 minus 3/4. Z equals negative 2 minus 3 over 4. Negative 2 minus 3 is negative 5, so z is negative 5/4. Y minus 1.23 is equal to negative 0.02. I will add 1.23 to both sides to isolate the variable y. So y would equal negative 0.02 plus 1.23. Adding numbers with different signs, we remember to keep the sign of the larger, so it would be positive. And subtracting the values, let me do a little side work down here. 1.23 minus 0.02 would be 1.21. The multiplication property of equality tells us that we are allowed to multiply both sides of an equation by the same non-zero number, and that results in an equivalent equation. So for example, if I had 1/3 x equals 7, I'm allowed to multiply both sides by 3. Now why 3? Well, what's 3 times 1/3? 3 times 1/3 is 1. So I now have 1 times x is equal to 21, and 1 times x is x, so x equals 21. Now I have negative 2x equals 8. What could I multiply both sides of the equation by to get a 1x? I would multiply both sides of the equation by negative 1/2. Because negative 1/2 times negative 2, since they are reciprocals, is 1 times x. 8 times negative 1/2 is negative 4, and so I have x equals negative 4. Now, you may have learned somewhere in the past that you could just divide, and that's really what I did, because division is the same as multiplication by the reciprocal. So if we start off again with negative 2x equals 8, and we divide both sides by negative 2, negative 2 divided by negative 2 is 1x, so we have 1x equals negative 4, x equals negative 4. But it's often useful and helpful to remember that we could multiply by the reciprocal of the coefficient on the variable. All right, so here are a couple. I would like for you to try these on your own. Now would be a good time to pause. $25x equals 0. I would divide by 25. 25 divided by 25 is 1, so I have 1x. 0 divided by 25 is 0, and so x equals 0. Or the solution set contains 0. Negative 4a equals negative 32. Dividing by negative 4. Negative 4 divided by negative 4 is 1 times a equals negative divided by negative is positive 8, and so a equals 8. Here are a couple more that I would like for you to try on your own. Now would be a good time to pause. Three-fourths x equals 5/8. All right, so now here is a situation where you really want to remember to multiply. The coefficient on the variable is 3/4. So if I multiply by 4/3 on both sides, 4/3 times 3/4 is 1. So I have 1 times x equals, now multiplying here, I'd have 5 times 4, and let me think of that 8. That 8 is a 2 times 4, so I can remove the common factors right away. So I now have x equals 5/6. And of course I can check my work here, and I've been negligent in this. I haven't been practicing that. So let's check our work. 3/4 times 5/6. Is this equal to 5/8? Well, I have 3 times 5 over 4, and the 6 is 2 times 3, and I can remove the factor of 3, and that does give 5/8. So x equals 5/6 appears to be appropriate. Going to the second one here. Negative 3/4 is 1/8 y. I would multiply both sides by 8. 1/8 times 8 is 1, so I now have 1y. Thinking of that 8 as an 8 over 1. I have negative, right, because I have a positive times a negative, and I have an 8 times 3 over 1 times 4. And let me think of that 8 as a 2 times 4, so I can remove the common factor. And so I would have negative 6 is equal to y. Checking my work. Is negative 3/4 the same as 1/8 times negative 6? Thinking of that negative 6 as a 6 over 1. I would have a negative, and then I'd have a 1 times, and let me think of that 6 as a 2 times 3. and that 8 is a 2 times 4. And removing the common factor, I do get negative 3/4. All right, let's look at some more. Negative 10 is equal to negative 4x. I would divide through by negative 4. So that would give me a 1x, or simply x. And on the left-hand side, I've got negative 10 divided by negative 4, and that division doesn't go smoothly. I know it's a positive, but let me think of that 10 as a 2 times 5, and that 4 is a 2 times 2, and removing the common factor of 2, I would have x equals 5 over 2. Checking my work. Negative 10, is that equal to negative 4 times 5 over 2? Treating that 4 as a 4 over 1, I would have negative, right? A negative times a positive is negative. And let me think of that 4 as a 2 times 2 times 5 over 1 times 2, and removing the common factor. That would give me negative 10 over 1, which is negative 10. 0.3 times y is equal to 1.2. Dividing by 0.3, y would equal, let's see, let's do a little bit of long division here, 0.3 into 1.2. Remember that we move our, if we have a decimal divisor, we move it to the right to make a whole number, and we do the same in the dividend, the inside. And so we now have 3 into 12, which is exactly 4. So y equals 4. Checking our work, 0.3 times 4, is that equal to 1.2? 3 times 4 is 12, and 1 decimal point. So bring it in from the right, 1.2. Yes, it works. An acre equals 43,560 square feet. Write a formula that converts acres to s square feet. Right, so we saw an application like this way, I don't know, maybe early in chapter 1. But what I would do here is start with a table. So let's see, acres, square feet. 1 acre is 43,560 square feet. If I needed 2 acres, I would take that number of square feet and I would multiply it by 2. And if I needed 3 acres, I would multiply 43,560 by 3. And if I had A acres, I would have to take the 43,560 and multiply it by A. So the formula is the number of square feet is 43,560 times A. So there's part A of the exercise. Part B. Use your formula to write an equation whose solution gives the number of acres in 871,200 square feet. So we are given a number of square feet. That's a value for S. So for B, the equation would be, when is 871,200 equal to 43,560 A? There's the equation. Then for part C, what we would need to do is divide both sides of the equation by 43,560. Now, of course, dividing by 43,560 is not a simple task, but you should be able to go through this and find that if you solve this correctly, 20 is the quotient. And so we would have 20 is equal to A. And so therefore, we would have 20 acres. All right, and one more application to finish the section. If an employee's salary is multiplied by 1.06, which corresponds to a 6% raise, the result is 58,300. Find the employee's current salary. All right, so the current salary is unknown. So let's call it X. It's multiplied by 1.06. So 1.06x, the result is 58,300. All right, so to solve the equation, we simply need to divide by 1.06. And I'll go through this one with you. All right, so we'd have 1.06 divided into 58,300. And what we want to remember here is that we don't like a decimal divisor, so let's bring the decimal over 2 places and up. And now we follow through with the division process. 106, it looks like it'll go in 5 times. So it doesn't go into 5, it doesn't go into 58, but it appears to go into 583 5 times. And that would be 530. So subtracting that gives us 53, and we bring down the 0, and let's see, 530 was exactly 5 times, wasn't it? And so then we would bring in zeros for all the remaining places, and so X is 55,000, and that would be in dollars. $55,000 is the current salary.